The electromagnetic spectrum extends from the frequencies used for modern radio at the long wavelength and through thousands of miles down to the fraction of the size of an atom. Imagine there's a magical rainbow of invisible waves. Some waves are as long as a whole school bus, while others are tinier than a crumb. This covers an electromagnetic and electromagnetic wave energy having wavelengths from gamma radiation at the short wavelength end to microwaves. Think of these waves like different sized stones. Some are so small you'd need a super microscope to see them, and others are as big as your microwave at home. For example, 1.5 times 10 raised to the power 4 hertz at about 20 kilometers to 3 times 10 raised to the power 14 hertz, which is 600 nanometers, while the human eye is able to perceive the narrow band in this line which makes up visible light. Our eyes can only see a tiny part of this rainbow. It's like a special color club just for us. It's called visible light. The human eye is able to perceive wavelengths between 1.5 times 10 raised to the power 4 hertz. We have about 5 times 10 raised to the power 4 hertz into bracket 600 nano nm, while the usable radio waves extend to every narrow range since light frequencies consequently build as blinders surrounding the earth, though it could be said to be a good thing if the greater number of radio waves were radiating have otherwise paint a very chaotic picture. The earth would have otherwise created a very chaotic picture. So our eyes are picky. They only like certain waves, but that's okay because too many radio waves would make our world look wild, like a colorful mess. Electromagnetic energy at a particular wavelength lambda in vacuum has an associated frequency and photon energy E. Light is a kind of energy that moves in waves. Each wave has a size into brackets wavelength, a speed of wiggling into brackets frequency, and an amount of power into brackets energy. The EM spectrum may be expressed equally well in terms of these quantities. We can describe light using any of these three things: its wave size, its wiggle speed, or its power, which is E is equal to HF or E is equal to HC on lambda. These are special mark rules that show how the wave size, wiggle speed, and power of light are connected to each other, where H is Planck's constant, C is equal to this value, and then these are special numbers that scientists use when talking about light. H is a tiny number and C is the super fast speed of light. High frequency EM waves have a short wavelength and high energy, whilst low frequency EM waves have long wavelength and low energy. Light that wiggles very fast has short waves and lots of power. Light that wiggles slowly has long waves and less power. It's like comparing a quick energetic puppy to a slow sleepy turtle. Here is a table simplifying the electromagnetic spectrum used in electronic communication. The class, wavelength, frequency, energy. So we have the extremely low frequency, super low frequency, voice frequency, very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, extremely high frequency, infrared, and visible light, with their wavelengths, their frequencies, and their energies.